Hi, welcome. This is analysis of algorithms, and we're doing the homework problems for analysis of algorithms. I'm going to say this every time at the beginning of every single video about the homework problems is first do the homework, then use this to check the homework, or to see how to do it if you can't do it, but spend time struggling over doing it. Okay, so we start with, we usually do one homework per chapter that we're going to cover, but I have a homework called Homework Zero. I'm going to try to put a link at the bottom to this homework. It's a homework that's getting you to just make sure you understand how to go from how much time does an algorithm need, how long does it take, how fast does the computer have to go. And so you can read it on your own if it's hooked. There's four things here. There's the rate of growth of the algorithm, so f of n is equal to something something. Then there's the size of the input, then the speed of the computer, and then the time to solve these problems. And what we said in class was, for every three of these, there's you can figure out the fourth. So that's what we're going to do here. It's three little problems, and it's worth going through it. Okay, so let's start. Problem 1. Consider an algorithm that demands 23n squared. So f of n, so this is problem number 1. F of n is equal to 23n squared. Okay? Operations for ops. So that's how many operations it needs for an input of size n. Okay, part one, there's two parts to each one of the problems. Part A, how many operations per second would your computer have to do in order to complete an input size 110 minutes? Okay, so let's work it out. So basically what you have to do is, you have an input of size 100. Okay, and so you plug it in there, you get 23n squared. Whoops, 100 squared. Okay. I apologize, it's a tough day. 100n squared. Should help with the voice. 100n squared. 100 squared. Okay. This turns out to be 230,000 operations. That's what you need. Okay? And you want to do it in 10 minutes. So 10 minutes is equal to 600 seconds. Okay? And the question is, how many operations per second would your computer have to do in order to complete an input of size 100 in 10 minutes? Show will work. So basically, you'd have to do 230,000 operations in 600 seconds. So how many operations per second? Okay, and the answer is, again, I worked it out with the calculator, is 3,833 operations per second. Just divide it. Okay. Part B. Let's be about part B. Assume the computer does 50,000 operations in a second. What is the largest amount of input that can be done in an hour? Okay, so let's work it out. B. 1 hour. Good Lord. 1 hour is equal to 60 minutes, which is equal to 3,600 seconds. Okay, that's how many seconds you want. Okay, now assume the computer can do 50,000 operations in a second. So that's 3,600 seconds. And each one of those seconds, he can do 50,000 operations. Okay, and if you multiply that out, you get 180 million. Nope, that doesn't work. 180 million. This is seconds. This is operations per second. So that's 180 million operations. Okay? Okay, great. Now let's read the question again. Always come back to it. Assume the computer does 50,000 operations in a second. What is the largest amount of input that can be done in an hour? So 36. This is how many. This is an hour. This is how many. This is how many operations per second. This is how many operations altogether. And so what we have to do is solve. 23n squared is equal to 180 million operations. OPS. Okay? And simply solve for n. So you divide by this, you get n squared is equal to, divide by 23, you get 7,826,086. Okay? And so you get n, which is equal to square root of n squared, which is equal to square root of 7,826,086, which is equal to 2,796. So that's what n is. That's the largest size input you can do. 2,797. Okay? So that takes care of that. Okay, press pause. Make sure you got the same answer. Okay, great. Number 2. Okay, number 2. Problem 2. Okay, let's read it. Assume you run a program on a computer that does 100 operations in a second. 100 ops in a second. That is pretty slow, but that's not important. We're just doing the math. We're just learning how to do the math. Okay? Let's say the algorithm does, here's the algorithm, f of n is equal to 3 to the n plus 2,000. I made up this number because I wanted something in the exponents, because I want to show you how to get rid of the exponents. Okay? Okay. Let's say the algorithm does 3 to the n plus 2 operations for input size n. Okay, good. Now, question A. You ready? A. How many hours will it take for your computer to do an input of size n is equal to 100? Okay, so we work it out. The input size is a 10. I'm sorry. How many hours will it take for your computer to do an input of size n is equal to 10? Show will work. So we're going to do that. 10, which is equal to 3 to the 10 plus 2,000. Okay, which is equal to 59,049 plus 2,000. Okay, which is equal to, just 59,000 plus 2,000 is 61,049 operations. That's how many operations 10 input demand. Okay? Now, you can do 100 operations in a second. Okay? So, you could do 61,000 operations. And if you could do 100 operations in a second, how many seconds would that take? Okay, and so you divide this by 100, okay, because there's 100 seconds, 100 operations in a second. Okay. So, okay, this will tell you how many seconds you have. And the answer is 610.49 seconds. Okay, basically chop off two numbers because you're dividing by 100. 610 seconds. Okay, great. How much is 610 seconds? That's 10, this is equal to 10.174 minutes, which is equal to, okay, divide that by 60, so that it becomes 0.16958 hours. Okay. It says, show will work. How many hours will it take? So that's how many hours it will take. 0.16958 hours. Okay, part B. Let's do this. What size input can the computer do in a 5-hour period? Okay, so we have how many operations in a second, we have the functions. Now we're given how much time, and so we want to know what's the n. Okay, so let's work it out. 5 hours is equal to 60 minutes in an hour, is times 5 times 60 is 300 minutes, okay, which is equal to 18,000 seconds. Okay, that's how many seconds in 5 hours. Okay, now you could do 100 operations in a second. Okay, so that becomes, just move over to put in 2 more. So this is equal to 18000 and 2 more zeros, and you get 1,800,000 operations. Okay, so that's how many operations can be done in 5 hours. Let's read the question again. What size input can the computer do in a 5-hour period? So in 5 hours you can do that many operations, okay? And so now we have to see what's the size input. 3 to the n plus 2,000 equals 1,800,000 operations. Okay, and basically we're solving for n. Okay, so not hard. What we do is we bring the 2,000 over, so we get 39, 3 to the n is equal to, big pain in the neck, 1,798,000 operations, okay, and we solve for n. Okay, I did this specifically because I wanted this thing. I want to get rid of the 3 over here. It's 3 to the nth power. The only way I know how to do it is divide by log base 3. I'm sorry, apply log base 3. Log base 3 of 3 to the n is equal to, on this side will be n. Well, if you're going to do it on this side of the equations, you better make sure you do it on the other side of the equation. Okay, so you take log base 3 of 1,798,000. Okay, but your computer probably does not have log base 3, but your computer does have ln. So we do it as follows. Ln of 1,798,000, okay, divided by ln base 3. Okay, and that's something we'll see in chapter 3, but you'll know how to do it. Well, you should know how to do it anyways before. Anyways, you get out the final answer 13.109. That's your size n. N is equal to 13.109. That takes care of that. Let me just give you the secret formula for this. Log base b of x is equal to log base a of x divided by log base a of b. Okay, so if your computer only has log base e, whatever the hell that is, e, okay, then you can do that. So another way of saying that is log base b is ln of x, that's 1, instead of the a we have e, divided by ln of b. Finished. That takes care of that. Okay, so that's your final answer. Okay, I'm sorry I didn't do this final answer, that's my final answer here. Okay, great. Final problem. Final problem is even. Okay, so 1, 2, 3 is the third problem. You have an algorithm that works with 50n to the third. F of n equals 50n to the third. Okay, and an input of size 2000. N is equal to 2000. Okay, if you implement the program on a computer that does 1,000,000 operations in a second, so one operation is in a microsecond, how long will it take in days? So let's do it. You ready? So this is A. You ready? F of 2000 is equal to 50 times 2000 to the third power. Okay, which you can plug in, or just 2 times 2 times 2 is 8. 8 with a lot of zeros. So this turns out to be, and multiply that by 50, so you get 4 times 10 to the 11th number of operations. Okay, great. So that's how many operations. Let's read the question again. If you implement the program on a computer that does 1,000,000 operations in a second, how long will it take in days? Okay, so you have this many operations. Okay. You have this many operations. Sorry about that. You have this many operations, and you could do 1,000,000 operations in a second. That means, question, how many seconds will it take? So you could do 1,000,000 operations in a second. Okay, and so we get out, how long will it take in days? Okay, so that's equal to 400,000 seconds, which is equal to 666.6 minutes, which is equal to divide this by 60, you get that many minutes, divided by 60 again, you get this many hours. Okay, divided by 24, because it gives you how many days, you get 4.6296 days. That's your final answer. Okay? Okay, let's do the last part, second part. Okay, rather than going down, let's erase this. Okay, how many operations per second would your computer have to do if you wanted the job to be done in 30 days? Okay, how many operations would... Let's read that again. How many operations per second would your computer have to do if you wanted the job to be finished in 30 days? So let's work it out. 30 days, this is part B. 30 days is equal to, multiply that by 24, multiply that by 60, multiply by 60 is equal to 2592 seconds. 2,592,000 seconds. Okay? Now, your computer can do 4 times 10 to the 11th operations. Let's just read the question again. You have an algorithm that works 50n to the third and an input of size 2000. Okay, so that's how many operations are needed. How many operations per second will your computer have to do if you wanted the job to be finished in 30 days? Okay, so the answer is as follows. You have this many operations are needed. You have 259, in 30 days you have 2592000 seconds, and so if you divide that you get 154,320 operations per second. That's how fast your computer has to do if it wants to finish this many operations in this many days. Okay? Okay. The homeworks are pretty much going to go the same type of way. Hope you enjoyed. Thank you very much.